welcome everyone. Now we are going to talk about parallelogram. So what do we know? That's a quadrilateral shape, so four sides shape and opposite sides parallel. So that side parallel to that one and this side congruent with the opposite sides. Same idea for the other pair. So opposite sides must be parallel and this side must be congruent. If opposite sides parallel, we call it parallelogram, or if opposite sides are congruent, we call it parallelogram again. So there is another parallelogram you can see here. These are parallel, and these two, you need to use another mark here. Let's use two arrowhead. So these two parallel and these two opposite sides are parallel. This is first. Second, let's talk about angles. And if you talk about angles, opposite angles are congruent. So that angle is congruent with that one, and this angle congruent with opposite of it. So that one. Or here, this angle congruent with opposite of it, and this angle congruent with opposite of it. So same marks show congruency. This is second thing, so you have to know. Such as if this is 120, so opposite of it 120. There is another idea comes up. So if this is a parallelogram, so if this angle and this angle will corresponding, they are corresponding angles, and put here another one, they are congruent. Together they makes 180 degrees if a straight line, if that's a straight line. So together it makes 180 degrees. Therefore I can say sum of these two angles, so that 120 and this one must be 180. So 120 plus that one equal 180. So x equals 60 degrees. So that's equals 60 degrees. And this must be 60 degrees. We can say here the same idea. It's work for all parallelogram. Oops, sorry. Let's lock that shape. So I don't want to delete it anymore. So here we can say consecutive angles, so that one and that one, if you add these two, it makes 180. Or if you add these two angles here, 180. Or if you add any consecutive angles, we call them consecutive angles, not opposite angles, it's all time must be equal 180. So sum of the two consecutive angles must be equal 180. There are some properties of a parallelogram. Let's draw here a parallelogram. That's good. Let's lock it. I don't want to delete it. Okay. Let's write some letters corner. A, B, C, D. Okay, so let's say length of the BC, so length of the BC is equal length of the AD, so opposite sides congruent. Length of the BA, so ABA, that one, it's congruent with length of the CD, so opposite of it. So opposite sides are congruent, we already told that part. Another part here, okay, angle B and angle D congruent. Angle A and angle C congruent. As you see, angle B and D, angle A and C congruent. This is the second is given. Here it say angle B plus angle C. Angle, so sorry. Oh, I clean all of it. Okay, let's check that one. Let's change color. Angle B plus angle C. So these are consecutive angles congruent. A and D 180, as you see, they are not congruent, sorry. B and C, it's add up to 180, so sum of AB it's equal to 180. Or let's continue, B and A, these two, when you add them, it's equal 180. D and C, so these are consecutive angles. When you take choose two consecutive angles, when you add them, it's all time equal 180 degrees. So this is the given here. One more thing left, I think, for us. The important, maybe it's a bit important. What is written? In a parallelogram, diagonals bisect bisect each other. So diagonals bisect each other. What does it mean? That's first for diagonal. I could draw it. Let's choose a line here to draw a good line. That's from here to here. That's first diagonal. Let's lock that one. That's good. And another diagonal here. Okay. Let's lock that one. So diagonal bisect each other. So that one and that part is congruent. This part and this part, they are congruent. So when you see diagonals, they bisect each other. It's half and half. Here another idea I want to mention. Because of this parallelogram, I can't call. If I say that's angle, so there is an alternate angle of here. Or this angle, it's alternate, it's here. So you can say about this angle and this angle, or these are alternate. You can find others yourself. We can use it. There's a shape given and it says it's in a parallelogram. It's given. Find each measure. JK. First one is JK. How can I find JK? JK is 7x given, and opposite of it here 3x minus 14 is given. So what I know, 7x and 3x 14, they are opposite sides, so they are congruent. For question 1, if they are congruent, so as a measure they are equal. 7x must be equal 3x plus 14. So minus 3x minus 3x from the algebraic expression. 4x equal 14 divided by 4 divided by 4. X equal 3.5, not 4, sorry, 3.5 divided by 7 and 3.5, yes. What is my question here? JK. What is JK? 7x. What did I find the value of x? 3.5. So 7 times 3.5, 7 times 5, 35, 7 times 3, 21, 24.5. So JK equal 24.5. What about LM? I'm not going to calculate 3 times 3.5 plus 14. Why? Because they are congruent. So if this is 24.5, this must be 24.5. So I'm going to write 24.5. This is the second question. Let's come to question 3. Angle L. What is the measure of angle L? What is angle L? 2z minus 3. And there is another angle given, 5z minus 6. What I know about these two consecutive angles? When you add two consecutive angles, it must be equal 180. So 5z minus 6 plus 2z minus 3, it's equal to 180. So there's adding by algebraic expressions. You can check that one either. 5 plus 2, 7z minus 6 plus minus 3 minus 9 equal 180. 7z equal 189 divided by 7 divided by 7. So z equal 18 divided by 7 to 14, 49. So 27. Sorry, 27. Yeah, z equal 27. But I find the value of z. What is the question? Measure of angle L. So measure of angle L, it's equal 2 times 27 minus 3. So 2 times 27 is 54. 2 times 27 is 54 minus 3, 51. Okay, I find the measure of L is 51. What about measure of M? If this is equal 51, so I'm going to solve question 4 here. I'm not going to use this given algebraic expression. Why? If I know question the value of L, measure of L plus measure of M must be equal 100 up to 180. So 51 plus measure of M equal 180 minus 51 minus 51. Measure of angle M equal 129 degrees. I forget the degrees here, sorry. So that's how we use properties of parallelogram. Okay, let's see this question. It's a proof question, and read the question carefully here. PSTV, that's shape here, that's a parallelogram. This is first given, and PQ and RQ are congruent, so that's an isosceles triangle. If it's an isosceles triangle, I can say angle P congruent with angle R. So this is easy. So what is question? Show that angle STV congruent with R. So STV is here. But I know because of parallelogram, because of PSTV is a parallelogram, measure of P, or let's say angle P, is congruent with angle STV. These are congruent. So angle P congruent with angle R, because of this is isosceles. PQR is an isosceles triangle. Therefore, as you see, P is equal S angle STV, P congruent with angle R, so both of them congruent with P, they must be congruent each other, so both of them say same value. Angle R congruent with STV. So because this is because of the parallelogram. I wrote it actually. Okay. This will help us to understand how we prove the questions, same questions such as question 6. Okay. Come on. Okay, first one is if one pair of opposite sides of a quadrilateral are parallel. So one pair opposite sides of a quadrilateral parallel and congruent. So one pair opposite sides parallel and congruent. So the quadrilateral called parallelogram. This is first. Second, if both pair of opposite sides of a quadrilateral congruent, then the quadrilateral is a parallelogram. So even you don't know it's parallel or not. If the opposite sides are congruent, it must be parallelogram. But both opposite sides. Again, if both pairs of opposite angles of a quadrilateral are congruent, so if you know about the opposite angles congruent and you don't know this is a parallelogram or not, you don't need to be afraid about it. You can say this is a parallelogram. If the diagonals of a quadrilateral bisect each other, so we call it again quadrilateral. So here we will use the first one to solve question 6. What is it? If one pair of opposite sides quadrilateral parallel and congruent, we can call this quadrilateral parallelogram. So as you see, there's an question on the question. It will ask us SCLH is a parallelogram or not, because it's not given and it says prove it. Show that one. Let's show it. So CDLH, that's a parallelogram. I can say that SD, so that's all line, is parallel to LH, and because these are opposite sides, so I can say these are congruent. C is the midpoint of ST. As you see, C is the midpoint of ST. Because of that, DC and CS are congruent. So what did I get here? Because of SC is congruent with LH and because they are parallel, so I find, let's write it, SC parallel to LH and it must be congruent, and they are congruent as you see because of C is midpoint. So SC congruent with LH, CSLH is a parallelogram. Parallelogram. So that's the easiest one. If you know the theorem of the parallelogram, so you can use this information to show a quadrilateral parallelogram or not. Let's talk about the rectangle and rhombus. So this will be end of this video. All rule of parallelogram works for rhombus and rectangles. So because they are at the same time as parallelogram, so all rules of parallelogram it's same for rectangle and rhombus. And everyone knows when we talk about rectangles, angles are 90 degrees and opposite sides are congruent. So you know that one. The new information, diagonals are congruent. So this diagonal is congruent with that one. And as we mentioned, diagonals bisect each other because of the parallelogram. These all congruent sides. These are all congruent lengths. Let's lock that one here. Delete. So that's first. This is about rectangles. That's one easy. But let's come to talk about this rhombus. So diagonals are perpendicular. So if it's a rhombus, this angle must be 90 degrees. So in a rhombus, diagonals bisect opposite angles. So as you see, these angles congruent and these angles congruent. If you remember, when we talk about a rhombus, opposite angles must be congruent. So that angle equal to that one and that one and that one. Same goes for these angles. And I do not say same things again, but let's mention it. Diagonals bisect each other. So these are all properties you need to know. If one of the parallelogram is a right angle, the parallelogram called rectangle. If the diagonals of parallelogram are congruent, then parallelogram is a rectangle. So there is lots of things. If one of pair of opposite sides of quadrilateral parallel and congruent, then it's a parallelogram. I think I didn't mention. I mentioned that one, yes, previously. Same things. Sorry, it's a bit late here. Let's skip that page. Let's solve some question and finish the video. The base of the bridge, so as you see, RSQP, yeah, RQPS is written, no problem. It's a rectangle. This is given as a rectangle. So this side, that shape is a rectangle. That's first. So what is given? RS is 4.8. QS, where is the diagonal? So diagonal is 11.14. Find each length. TQ, where is it? TQ. TQ is half of the diagonal, so 11.4 divided by 2 is equal 5.7. What about PQ? PQ is same with RS, so it's equal 4.8 meter. Let's write here meter. ST, so ST half of the diagonal again, it's same with the TQ. If I mention these are all congruent, so 5.7 meter. And PR, if you remember, diagonals are congruent, so QS and PR are congruent, so 11 is equal 11.4 meter. Okay, there is a garden. ST Garden Club is planting a rectangular garden. They drive pegs in the garden, so each corner to tie string between each pair. So as you see, they tied corners, so they are diagonals. The strings are diagonals here. So Vx is equal Vz, Vy equal to Vw. So diagonals bisect each other. So this and that one congruent. This one equal to that one. How can the garden club use the diagonal system to verify that the garden is a rectangle? So how can you think it's a rectangle or not? If the diagonals are congruent, the shape will be rectangle. So they need to check xz, is it congruent with wy. If these two congruent, so we can call this garden as a rectangle. MLBN is a parallelogram. So SML, this angle plus SNB, that angle, SNL. So this angle and this angle, it's 90 degrees. Prove that MLBN is a rhombus. So that's a rhombus. Let's think about it. If this is a parallelogram, I can call, because of the alternate angle, these two are congruent. And as you see, given this angle and this one is equal to 90 degrees, so this must be 90 degrees. So what is the rule? If diagonals perpendicular bisector each other, so they intersect with right angle, we call this shape rhombus. So that's all. Give sufficient condition in terms of diagonals of the quadrants for MRSY to be a square. So if we talk about square, it must be rhombus. So the perpendicular, they must be intersect with right angle, and MR must be congruent with MS, not MR, I'm sorry about it. MS must be congruent with YR. So, and MS must be perpendicular, intersect YR. MS, it must be perpendicular to YR. So, they must be perpendicular each other. So, that's all. Right angle. Okay, the last one, there is a circle is given. So, if RSYM is a, if it's so, what can we say here? Again, this must be 90 degrees. So if this is 90 degrees and if this is the center, that's enough. That's enough to make MRSY a rectangle, a square. I think that's enough. It's the end of the video and it's become boring. I will take another video about